to the same extent, but that Objective-C does, is you can automatically create all of these getters and setters for you, even in a more effective way than PHP's __ get and set. So let me go ahead and open up version 3 of this here. And in version 3, notice what I've done in my .h file. So has anything changed? Little sanity check. Has anything changed in my interface declaration for my instance variables versus the last example? Someone go on the record with a yes or no. OK, good. So nothing's changed. So that's exactly the same. So this stuff is also the same. This stuff now is new. So notice we have at property. So here in answer to Kevin's question about the @ sign, again, it's being used here for a new piece of syntax. At property, we have some kind of comma-separated list of things inside of parentheses. Then we have, OK, now it's familiar, int age, NSString, star name. So let's come back to what this means in just a moment. And let's look instead at the .m file. And what we have in the .m file is this. So same deal as before, where I do have these getters or setters. But the advantage now is that we're one step closer to being able to do this automatically. So notice here we've done a few things. At property, int age, at property, NSString name. What this is going to allow us to do next is, one, automatically create all of those getters and setters. We'll soon be able to delete all of those. And it will also let us invoke these things using a slightly more friendly dot notation. So you might recall from Java and other languages, instead of using arrow notation all over the place, you can do something like s.foo. And one of the things you get with Objective-C properties is that rather than have to say something annoying like this all over the place, open bracket s space foo, close brace, which recall we did in the greet method, right? Instead of saying something like this, s arrow foo, we had to say open bracket s space foo. It just becomes a mess. It's really hard to read, certainly in longer chunks of code. Soon we can start saying s.foo. So the mere fact that I've still implemented in this version 3 all of my getters and setters, but I've told the compiler to make me properties called age and name, what this is going to do for me is ensure that I can actually start using that dot notation already. So it's just syntactic sugar, but this tends to be a nice thing, especially when you start writing the same thing again and again. And we'll come back to this in just a moment. So that's going to allow me to use, in short, a little notation like this down here. Alice.age gets 20. Alice.name gets at quote unquote Alice. This is in contrast to what? A moment ago, these calls looked like what instead? This was Alice set age 20. And this other one was Alice set name colon at Alice. So what has the mirror use of the at property keyword done for us? Well, one, it's literally let us rewrite these two lines as these two lines. And they're arguably cleaner, right? They do the same thing. How did it do that? Well, this is mostly by way of convention. The reason that you should, even though you don't strictly have to, call your getters and setters foo and set foo with set capital F as a convention is when you start using the at property keyword, Objective-C, specifically the compiler, is going to assume that when you say Alice.age equals something, it's going to automatically call the setAge method on that object for you with the value that's on the right-hand side. So it's just, again, syntactic sugar. It's doing the exact same thing we could have done 5 minutes ago, but frankly, it's getting a little more familiar, a little friendlier, and just more readable ultimately. And similarly, if we now look at the greet method down here, notice this too. Come on, this is more readable than open bracket, s space, and so forth. And that's what we've gotten now with properties. But we can take this one step further. If I now go ahead and open up version 4, and again, all these files are available online if you'd like to tinker at some point. Now let me go into student.h, which looks a little different here. Notice that I've gotten rid of a few things. This is version 4 now. What's disappeared from this file? It's definitely different now. All the getters and setters have sort of somehow disappeared, and all of the instance variables have disappeared on me. So this does not seem good. This seems like a step backwards. But let me go to the M file, and oh my god, I can literally rip out all of the code I just wrote in Objective-C and simply say, synthesize me a property called age and back it with an instance variable called _age. I could call it anything I want, but this one-liner here is saying synthesize a property and make sure you use a variable called _age to store that property. The property is defined in the other declared in the other file, and we'll look at that again in just a second. But what this means more specifically is create automatically for me a getter and create for me automatically a setter without me writing a single line of code besides this one here. So this is a huge leap forward, frankly, because what we can also do now is also enforce a few constraints. So now we can tease apart this comma-separated lists. So at property, int age, at property, NSString star name, did all that. But what about these getters and setters that are going to be synthesized, that is automatically written for me by the compiler? They can adhere to a few attributes. So this comma-separated list, and the order doesn't matter. I tend to be anal and just alphabetize them. But assign means when you create the setter, go ahead and literally do _age equals age. So assign means literally implement my setter in a way that uses assignment, just like this. By contrast, and you can kind of guess now, when you say copy instead of assign, what kind of setter gets automatically created for you? _name gets, yeah, so the name argument that was presumably passed in to the setter, and then pass it the copy message. Where does the copy message, or where does the copy method come from? Where was it defined? So in the NSString class. In the NSString class. It's an instance method that you get for free. So that's the distinction there. So assign, this is OK. I don't need to copy the age per se. Why? Right, so it's a primitive you don't need to worry about. And specifically, I am copying it. But when you copy a primitive, you're literally copying those 32 or those 64 bits from the right to the left. So you actually do have a true copy. The problem conceptually with a pointer is that if you literally copy the pointer 64 bits over from the right to the left, what are you getting a copy of? The address, which is not what we want, because the name might mutate outside of the object itself. So copy in the sort of human what we mean sense is to actually dereference the pointer, copy the characters there into a new memory buffer, and return the address of that new buffer. So it's copy in the sort of human sense, not in the super literal bitwise sense. All right, non-atomic, atomic. So if you've taken CS161 or certain other classes, and we talked about atomicity earlier in this semester in the context of database transactions. If something's atomic, it means it all happens together without interruption or not at all. Non-atomic means you have no such guarantee. In this case here, I am writing the simplest of stupidest programs called Hello World. Like I don't have multiple threads running. There's no GUI involved here. There's no worry there's no need for atomic operations, because indeed, if you do use atomic operations, let's pretend we have no idea how they're implemented. They've got to take some amount of effort, some number of CPU cycles. So why bother? If you're not in a multi-threaded environment, there's no threat of multiple threads interrupting each other. You don't need to spend those extra CPU cycles, however much they are. For more on this topic, Google the terms locks or semaphores, or take CS161. All right. Lastly here, this one's obvious. Read-write means give me a getter or a setter. An alternative to this keyword is read-only, one word. And that just means give me a getter. Don't give me a setter, because I don't want the state to change. I can still initialize it with some other method, but I don't want to give it a setter property. So that's all those things mean there. So already, hopefully, Objective-C is getting kind of compelling. Let's skim to... let's do one other thing here real fast. So if you do nonetheless want to override one of these automatically synthesized setters, realize that this is possible. Notice that in version 5 here, this is identical. So no change to my declaration of a student. But if I do want to override, and this was the most clever thing I could come up with in the middle of the night, if I do want to override the setter would otherwise get generated for me, but I still want the property. I still want my syntactic sugar and my dot notation and all of that, but I don't want the default behavior for a setter because I want to do some validation or I want to do something stupid like this. Well, I can override what would have been automatically synthesized for me. And you can kind of see what this is. You can kind of infer pretty much what this thing is doing. There's some new syntax, so let's you emphasize the syntax and not the functionality. So if name is equal to string. So already, if you didn't like my PHP's long function names, get ready for Objective-C's. Is equal to string colon at David. So this is how you test two objects of type NSString for equality. Can't use equal equals, because what would you be comparing otherwise? The pointers, and we learned in 50 that's very bad, right? So here's how you do it at a higher human level. All right, so if the name is equal to David, well, this appears to be changing my name to dummy, but more interesting is how is it doing that? So underscore name, which is the instance variable that I have told the compiler to make sure exists, even though I didn't declare it anymore in my header file. This is, notice now the nesting. This is an incredibly common paradigm. In Objective-C, almost